Good morning dear students. I am Dr. Gauri, Assistant Professor at Department of Physics from Arts, Science and Commerce College, Ramanand Nagar, Broglie. Students, in today's lecture, we will discuss chapter Matter Wave, which is from BSc third year paper number 10 of Quantum Mechanics. In last lecture, we have studied about the introduction of quantum mechanics and the syllabus. In today's lecture, we will start chapter Matter Wave. So first, we will revise some points which we have discussed in the previous lecture. In last lecture, we have discussed that how classical mechanics fails and how quantum mechanics comes. Means why there is a need to study the quantum mechanics. So students, in the late 19th and early 20th century, physics experiments increasingly gain access to microscopic observables. Means attempts to describe atomic particles as point masses governed by the laws of classical mechanics. But there are some failures which are increasing in some experiments. Means classical physics which is failed to explain the thermal radiation, atomic spectra, intrinsic orbital angular momentum, superconductivity. So to overcome all this, the new field of physics come into across, which is called as the quantum physics. So quantum physics or quantum theory is based on the various basic principles such as energy quanta, wave particle duality and uncertainty principle. And the classical physics which is based on the Newton's law. Means classical physics which is based on the Newton's law, which is deals with study of macroscopic phenomena, while quantum mechanics is the study of the electron and high frequency electromagnetic waves, which deals with the study of microscopic phenomena. So this is the major difference between the quantum mechanics and the classical mechanics. Means classical mechanics deals with the study of macroscopic phenomena, while quantum mechanics deals with the study of microscopic phenomena. And various principles which are involved in the quantum physics, which are, first one is the energy quanta, which is given by E is equal to h mu. And second is the wave particle duality, which is lambda is equal to h by p. And third is the uncertainty principle, means we cannot determine the exact position of an electron. This is the uncertainty principle, which is given by delta x into delta p, which is greater than equal to h cross, where value of h cross is equal to 1.054 into 10 raised to minus 34 joule per second, and which is very small, so it's significant only in the subatomic level. So students, after discussing the need of the quantum mechanics, we will start our chapter Matter Wave. So dear students, do you know there are how many types of the waves? Yes, we have studied in the last year. Means in BSc second year we have discussed in detail what are the types of the wave. So students, once again I will repeat this. There are mainly three types of the wave. First is the mechanical wave, second is electromagnetic wave, and third is the matter wave. So do you know what is mean by mechanical wave? Mechanical wave is the type of the wave which needs the medium to travel. Okay, and example of these waves are air wave, water wave and rope wave. And again mechanical waves are divided into two types, transverse wave and longitudinal wave. Then electromagnetic waves are the types of the wave which do not require medium to travel. Means they can travel through the vacuum. And the example of electromagnetic waves are light wave, radio wave, X-ray and gamma rays. Okay, means the waves which are present on the electromagnetic spectra are the electromagnetic waves. Then third and main type of wave is a matter wave, which we will discuss in today's lecture. And these matter waves which are produced by the electrons and the particles. So students, all these are the types of the wave, and out of this we will discuss matter waves. So Here, look at here, this is the de Broglie's relation. Okay, he is de Broglie, and who invented these matter waves in 1923. So in 1923, Louis de Broglie postulated that ordinary matter can have wave-like property with wavelength lambda related to the momentum p in the same way as for light. And the de Broglie's relation, which is given by this equation, lambda is equal to h by p, where h is the Planck's constant and whose value is 6.63 into 10 raised to minus 34 joule second. So students, here in de Broglie's matter waves, wavelength depends on momentum and not on the physical size of the particle. So we have seen that the light come in a discrete units of photons. So what the lights come in the discrete units of the photon with particle properties such as energy and momentum that are related to the wave-like properties of frequency and wavelength. So these are the photons. So in next slide we will learn or we will discuss about the photons. What is mean by photons and what is the energy of photon. So photon, what is photon? Photon is a packet or bundle of energy which is called as the photon. A packet or bundle of energy which is called as a photon, and energy of photon which is given by E is equal to h mu. E is equal to h mu, where we know that this velocity is equal to c upon lambda. So here by putting this value we get energy of photon E is equal to hc upon lambda, where h is equal to Planck's constant, v is the frequency of the radiation or photon, and c is the speed of light, and lambda is the wavelength. So this is the equation for the energy of photon. E is equal to hc upon lambda. So after this we will discuss about the properties of photon. First property of photon is that a photon travel at a speed of light c in the vacuum. Means what is the speed of light? 3 into 10 raised to minus 8 meter per second. So photon travels at a speed of light in a vacuum. Second property is that it has zero rest mass. Means the photon cannot exist at rest. It has zero rest mass. Then third property of photon is the kinetic mass of photon is equal to m is equal to E upon c square. Here we use Einstein's relation E is equal to mc square. So by this we get value of m is equal to E by c square, and by putting value of E is equal to hc upon lambda we get final equation E is equal to h upon c lambda. Then momentum of photon is equal to p, and which is given by E upon c. So by putting this value of E here we get h by lambda. Means we have value of E is hc upon lambda, and by putting this value of E and c in this momentum equation we get value of P is equal to h upon lambda. So dear students, also there is another property of photon is photon travels in a straight line. Means photon always travel in a straight line. Then again energy of a photon depends upon frequency of the photon. So the energy of the photon does not change when photon travels from one medium to another medium. Means while traveling in one medium to another medium, the energy of photon remains constant. It can't change. So these all are the properties of photon and energy of photon. So after the discussion of photon, we will move towards the next slide, which will explain about the dual nature of radiation and matter. So dear students, as we know that wave theory of electromagnetic radiation explains the phenomenon of interference, diffraction, polarization. On other hand, quantum theory of electromagnetic radiation successfully explained the photoelectric effect, Compton effect, blackbody radiation and X-ray spectra. So this radiation have dual nature, means wave and particle nature. Okay, so again Louis de Broglie suggested that particles like electron, photon and neutron have dual nature. Means according to de Broglie, particles like electron, proton and neutron having dual nature. Means they can also have a particle as well as a wave nature. Means nature has a symmetry. As a light has dual nature. Light has a particle nature as well as a wave nature. So in no experiment matter exists both as a particle as a wave simultaneously. So it is either than one of the other aspect. Means the two aspects are complementary to each other. So on this suggestion he based two things. First is the nature loves symmetry and the universe is made up of the particles and radiation and both entities must be symmetrical. So this is the concept of dual nature of radiation and matter. Means every radiation have dual nature, means wave and particle nature. So this was suggested by the de Broglie's. Means particles like electron, proton, neutron have dual nature and they can also have particle as well as a wave nature. So after this we will discuss finally the de Broglie's view. Means what is the dual nature of the light and what is de Broglie view. So students, according to de Broglie, a moving material particle can be associated with a wave. Means a wave can be guide the motion of the particle. So students, look at here. Here there is one particle and a wave is associated with this particle. The wave associated with this moving particle and this wave is called as the matter wave. Means according to de Broglie, the wave which is associated with this moving particle is called as the matter wave. Okay. So in this figure, according to de Broglie, according to quantum theory, the energy of photon E is equal to h mu. Means E is equal to h mu means hc upon lambda, which we have discussed in the last slide. And according to Einstein's theory, the energy of the photon which is equal to E is equal to mc square. So we have lambda is equal to h upon mc and lambda is equal to h upon p. Means lambda is equal to h upon mc or lambda is equal to h upon p. We know p is equal to momentum. As we know that p is equal to mc, which is the momentum of the photon, and instead of a photon we have a material particle of mass m moving with velocity v. Then our equation becomes lambda is equal to h upon mv, which is the expression for the de Broglie's wavelength. Means here once again I will repeat. Here what is this? This is the, we have equation for the energy of photon is equal to h mu, then which is hc upon lambda, where we know according to Einstein theory E is equal to mc square. So if E is equal to mc square, then lambda becomes h upon mc. Here we put this value of E inside this equation and we calculate this value of lambda which is equal to h upon mc, or we know that value of mc means momentum. So by putting p is equal to mc, we get lambda is equal to h by p. So instead of photon we have a material particle of mass m which is moving with velocity v, and then equation which is become lambda is equal to h upon mv. Means here p is equal to mv. What? P is equal to mv, which is the momentum of this photon. So lambda is equal to h upon mv, which is the expression for de Broglie's wavelength. So after expression of de Broglie's wavelength, we will discuss the properties of matter wave. Means what are the various properties of matter wave. So dear students, there are so many properties of matter wave, out of which first property is wavelength of matter wave is given by lambda is equal to h upon p, where p is equal to mass into velocity. So wavelength of the matter wave, which is given by the relation lambda is equal to h upon mv. Then second property is that it is seen that as mass increases, its wavelength tends to 0. Thus, the wavelength of the macroscopic bodies is insignificant in comparison to the size of body even at very low velocities. Means we have formula lambda which is equal to h upon mv. So as mass increases, means if mass increases, wavelength going on decreasing, means here there is an inverse proportion between lambda and mass and velocity. So as wavelength of microscopic body is insignificant in comparison to the size of body even at a very low velocities. So third property of the matter wave is that de Broglie's wavelength associated with microscopic particle which is significant. Means de Broglie wavelength is associated with microscopic particles, not macroscopic particles. Third is that matter waves are produced by the motion of particles and are independent on charge. Therefore, they are neither electromagnetic nor acoustic waves but are new kind of waves. Means matter waves which are associated with what? Matter waves are associated or they are produced by the motion of particles. Okay? Means matter waves which are produced by the motion of the particles and they are not associated with the electromagnetic or acoustic waves. Then next property is they can travel through vacuum and do not require any material medium for their propagation. Means they can travel through any medium or they can travel through vacuum. Next is smaller the velocity of the particle, the longer is the wavelength of the matter wave associated with it. Means here we know that lambda is equal to h upon mv. Means here if the velocity is smaller, then wavelength becomes what? Longer. Because here there is a inverse proportion between the wavelength and velocity. Then next is the velocity of matter wave depends on the velocity of material particle and is not constant value. Means matter waves always associated with the moving particles. So because of that, it should have the velocity with it. Then next one is the velocity of matter wave is greater than the velocity of light. This is important thing. Means the velocity of matter wave which is greater than the velocity of light, speed of light. Then matter waves exhibit diffraction phenomenon as any other waves. So all these are the properties of the matter waves, and up to this we will stop here, and students, in the next lecture we will discuss or we will come with the new point. So dear students, we will stop here. Thank you.